Alrighty, this can be a hard one today. Design movie rental system. You have a movie renting company consisting of N shops. Want to implement a renting system that supports searching for, booking, and returning movies. The system should also support generating a report of the currently rented movies. Each movie is a 2D integer array entries, where entries has a shop, movie, and price, indicating there's a copy of the movie at shop I with the rental price. Each shop carries at most one copy of the movie. The system should support the following functions: search, finds the cheapest 5 shops that have an unrented copy of the movie. The shops should be sorted by price in ascending order. In a case of tie, the one with the smaller shop should appear first. If there are 5 matching shops, then all of them should be returned. If no shops has a unrented copy, then an empty list should be returned. Rents a unrented copy of a given movie from a given shop. Drops off a previously rented copy. Report returns the cheapest 5 rented movies. The cheapest 5 rented movies as a 2D list where RES, the result is a shop, movie describes the cheapest rented movie was rented from the shop J. Movies and results should be sorted by price in ascending order, and in case of tie, the one with the smaller shop should appear. In case of tie, the one with the smaller movie should appear first. If there are fewer than 5 rented movies, then all of them should be returned. If no movies are currently rented, then an empty list should be returned. Oh boy. Okay. Well, certainly lots of parts here. So search finds the cheapest 5 shops that have an unrented copy of a given movie. So, finds the 5 cheapest shops that have an unrented copy of a given movie. Interesting. So let's see a search. So for this, if I wanted to be able to quickly search, would want a mapping for movie to shops. Mapping from movie to shops that have the movie, and the shops that have the movie should be a heap of prices, comma shop. So for every movie, I have a heap so that I know what the 5 smallest prices are. Or to get smallest 5 prices from the shops that have them. Yeah, in the case of tie, it'd be lowest shop, which is going to be sorted as well by ascending in a heap. The main issue with a heap is if you rent out a movie from a given shop, it could be in that heap, in which case you have to worry about how to denote that thing is rented out. Or would you rent out something that's so if, let's say, shop A, or let's say movie A, and the heap for that movie of 5 cheapest places to rent it would be like, let's say it's $5 from shop shop 1, $6 from shop 2, $6 from shop 3, $10 from shop 4, and $11 from shop 7. Now this heap is only guaranteed to have the smallest price be here, be at the front of the heap. I could keep a set of the stuff inside the heap to know what stuff is in there. But say it's let's say this is the heap for movie A, and let's say someone rents the 10 at shop 4. So what would I do? I would need to somehow denote that this is no longer valid in the heap, and you need to add another entry to the heap. So let's say for example I add 11 shop 20 into the heap. There has to be a heap here and maybe a second heap of from second heap of non-cheapest places to get the movie. So there's like the cheapest 5 and then the non-cheapest others. And might need to be a set in addition to a heap in order to quickly denote something's on or off. Or maybe I just have maybe when I pull stuff from the heap, I do a cross check to see if it's been rented. Finds the 5 cheapest shops that have an unrented copy of the movie. The shop should be ordered by price in ascending order. Alternatively, instead of maintaining a search, what if I just did this 5 times on the other heap? So I just have one heap of all the movies, pull 5 from it whenever I need to, and then put those same 5 back. Pull 5 from it, pull 5 stuff from it, double checking to see if that is a valid pull. Turns the cheapest 5 rented movies. Possibly the same movie. Turns the 5 cheapest rented movies. Alright, I'm gonna do the slightly slower way of maintaining one heap for every movie rather than the fastest heap or the cheapest heap in the other heap, to see if that works. That needs to keep track of the movies that you pull and re-add it to the heap afterwards. So it's not particularly fast, but maybe it might work. The fact that whenever you rent an uncopied movie, of a unrented copy of a given movie from a given shop. No, I think I probably need to maintain like the cheapest 5 and if I maintain a cheapest 5 and then okay. I don't know. Let's go ahead and start by creating some heaps for every movie. So self dot cheapest this is the default dictionary of heaps. The heaps have internal storage of a list originally for each movie. So the key here is the movie, and the value is a tuple that is the price and the shop. So for every entry, where the entry is shop movie price, I'll do self. I'll do self dot other. What's the term for not cheap? I'll do others. Movie heap, a heap of the non the other non 5 cheapest movie the heap of the cheapest 5 places price places for that movie. So the key here is the movie. Value is the price in a shop. Okay, so how to do this? So generally when you do something like double heaps where you want to maintain one heap to have like the top 3 out of 100 or something, then you always push it, always push new entries into other heap, and then transfer between top heap, top 5 heap, and other heap, depending on size of the heaps. So self.others for this movie. I want to do a heap push. The top that is the price in the shop. So like initially if both heaps are empty, the others in the cheapest, then it pushes onto other. So now other has 1 entry. And then as long as so you obviously want to transfer from the top of the other heap onto the self heap if the cheapest heap has less than the top 5. So if the length of self.cheapest for this movie is less than 5, then automatically transfer. So transfer being heap pop self.others of this movie. This is going to be price. I'll call this PS, price and shop. And then we push self.cheapest for this movie. Top of that is price and shop. Else so yeah, if there is there is I could possibly do this before doing this thing right here. Yeah, maybe this should be done, this check should be done before doing this. And then like skip and then do the default way, which is having to do some sort of exchange. So this avoids this actually. Okay, so if there's what's going on here? Push onto the cheapest heap this thing, skip everything else. Okay, so less than 5, the cheapest heap, auto push to that heap. So otherwise, what you do is push onto other heap and transfer between it. So so then what would happen? You take the top of self.others, you push onto the cheapest, and then actually the cheapest needs to be ordered by, you need to actually have the reverse ordering for the cheapest in that case, because then you want to have the 5th largest of the cheapest in order to know what to transfer back onto others. Like, so the cheapest is actually ordered by your top 5, where you actually want to know what the most expensive one is, because the most expensive one is the one that actually needs to be transferred possibly onto the others. Okay, so I think that means I need to do negative price here. Okay, and for the other heaps, you do want to know what the cheapest of the other heap is, so that you know like what the 6th element is, or what the, yeah, what's kind of like the 6th cheapest price is, to compare it with the 5th highest price in the cheapest heap. So I'll push this new item onto it. I take and then push it on, and then I pop off the top, I think. I think this is where I'd use push pop. A push an item onto the heap, then pop and return the smallest item from the heap. Okay. So I push the item. So this would in theory get the 6th largest. And then I add this item to the other heap. Here the price should be negative PS. So this is going to be the sixth largest. And then I add it to the cheapest. Where the cheapest wants to get the thing in reverse order. And now I push this thing again onto the other heap. I think this probably needs to be negative PS. Okay, so let's say my cheapest heap is like, I'm not going to worry about the shop, but let's say the cheapest prices were negative. So this is going to do in reverse order. So the cheapest prices were like negative 12, negative 10, negative 5, negative 5, negative 3. And my others heap was 13, 15, 17, 15, 20. So 13 is going to be the lowest of the other heap. 12 is the lowest of the cheapest heap. And let's say that the new prices, the new entry prices, let's say 11. So 11 gets pushed onto the other heap. That makes 11 the smallest element of the other heap. So it gets popped, and 11 is P. And then 11 gets pushed onto the cheapest heap, or negative 11 gets pushed into the cheapest heap, and negative 12 gets popped. And then negative 12 gets pushed onto the other heap, so 12 now appears here. So then after all this would be like negative 11, negative 10, negative 5, negative 5, 3, and the others would be like 12, 13, 15, so on. Shop's always positive. Price of the other heap is positive. Price of the cheapest heap is negative. Yeah, I think that's fine. Yeah. So this is fine as a way to initialize everything because there's no worry about outdated information of rented and unrented. Okay, I think maybe I can move on to the next method. So the next method is going to be search. Search the 5 cheapest shops to have an unrented copy of the movie. The shop should be sorted by price in ascending order in case of tie. Maybe Okay. I'm going to do search, ignoring the possibility that some of these could be rented right now. So search should just return the sorted version of the heap for sorted version of the heap for the movie. So return say shops is the list of self.others for this movie, self.cheapest. This needs to be updated. This is just ignoring renting, getting cheapest 5 shops for movie. So then I need to return, I need to sort that, shops, sort. Okay. And then rents an unrented copy of a given movie from a given shop. Rents an unrented copy of a given movie from a given shop. I think that means for every movie shop combination, I need to track whether or not it's rented or not. So I could use a tuple for that. Like a key, a default dictionary where you have a tuple that is the movie comma shop and a boolean for whether or not it's true or false. Okay. Self dot rented is a default dictionary of boolean. Is that default to be true or false? Well, you cannot directly additionalize default dictionary with a boolean literal like default dictionary false because false is not callable. Default dictionary lambda true. Using bool as the default dictionary without arguments will return false. Yeah, okay, that's fine. Initially, I'm going to assume that it's not rented. Okay. So self.rented for using the key that is shop movie. It's going to be true. Self.rented shop movie should be false when it's dropped off. Okay, So how does this play with the search? So if I rent it and it was one of the cheapest 5, then what does that mean? If I rent it and it was one of the cheapest 5, then I would need to pull out the next. I would need to add on to the cheapest another movie. I would need to put onto the cheapest another movie that is from the others heap that also hasn't been rented. I would probably need to push onto the cheapest heap everything from the top of the others heap that have been rented until I see something that is actually hasn't been rented from at the top of the heap. So move if this is in top 5 of cheapest for movie, transfer from top of other heap until 5 unrented. Until an unrented movie is transferred to maintain 5 valid unrented movies and cheapest. So we might need to also maintain a count because I don't necessarily know. Alright, I think count is an extra thing I need to worry about later on. So something like while. So first I need to know if this is the cheapest. Determine if part of cheapest. So the topmost thing in cheapest should be unrented, guaranteed. Topmost thing in cheapest should be unrented. Self.cheapest for this movie, the top of that heap, if that element is less than, say if this element here, which is Oh, I don't know what the price of this movie is. Fuck. Gosh dang it. I need to actually... I need to know the shop movie and price. For every shop and movie, what the price of it is. Okay. Keep track of price for every shop movie. What is the index for shops? Shops is from 0 to n. Movie is from 0 to 1 to 10 to the 4th. I could do a default dictionary of a list here, where the list's first element is whether or not it's rented, and the second element is whether or not it's the price of it. Alright, I'll think about whether I need to do that later on. I think the price is an integer. Pretty sure the price is an integer. Yeah. For every shop we price, push it here. Now do self.prices for shop movie is equal to this price. Otherwise, actually I need to do that for everything, so I can put that at the very start. Okay. Or cheapest. So let's say the price of it is equal to self.prices for this shop, comma movie. If the price, comma shop is smaller than or equal to the top of the thing, actually negative of it. Negative of it. So the boundary price would be something like negative 12. Boundary price is going to be something like negative 12. And if it was something that is the price is negative 5. So I do need to reverse the prices, I think. Say PS is the self.cheapest at 0 or movie the top of that heap. So if here this price, this shop, this shop is less than or equal to negative PS. Then this is going to be part of the cheapest heap. So I need to pull from the from the other heap till I can get something. So while true, while true, actually maybe it's while self dot cheapest or self dot other where this movie exists, there are other copies. I need to automatically transfer. Automatically transfer. So it'll be ps is equal to self.other or heap push heap pop. Others or others. For this movie. And then heap push self.cheapest for this movie negative ps, and then if this is if self.rented for this movie where the movie is defined as shop in the movie, shop movie, self.rented. Rented uses the same key as price, which is shop movie. Yeah, shop. If it's rented, or if it's not rented, then that's good and you can break. So keep on, so this loops while there's any other copies out there in the other heap, and take the cheapest of those, push that information onto the cheapest heap, and stop if that was an actual unrented movie. So this could, in theory, if everything else outside of the cheapest heap is already rented, this could, in theory, just transfer everything to the cheapest heap and not actually find anything. Not actually find anything. But I guess that's probably the best you can do. So if the price shop is in the cheapest, if it's not in the cheapest, then this copy of the movie that's to be rented is already in the other stack or the other heap, so it doesn't need to transfer at all. Doesn't need to transfer. Yeah. If you rent, you either rent from the 5 cheapest, in which case it needs to try to refill that heap, or you rent from the non-5 cheapest, in which case you don't need to do any sort of transfer. I don't think. Okay. Drop. Okay, so here, if you drop how's this gonna work? So I make it false if you drop and it's part. What does this mean? So if you drop off something that is within the cheapest stuff, so that might mean that the cheapest heap has now 6 items. So I need to move things from the cheapest heap to the other heap until I move something that is until I move something that is until I move something that has what does this mean? If you drop off a movie and that movie is part of the cheapest heap, let's say everything gets let's say everything gets borrowed, so everything technically would be on the cheapest heap at that point. Everything's on the cheapest heap at that point. Now you drop off something. If you borrow everything and everything's on the cheapest heap, but the cheapest heap doesn't have any actual thing that's available, then if you drop off something, then you technically don't want to move that single item off the cheapest heap. Maybe I need to keep a count of how many things are actually valid on the cheapest heap. Can I do it without a counter? In theory, the cheapest heap could have all the movies. This thing transfers pretty much everything regardless. If everything's rented out, it transfers everything to the cheapest. And so you have like, let's say there's 100 movies, 100 copies of a movie. They are all on the cheapest heap. Nothing's on the other heap. They're all rented out. And then someone drops off a copy, so that's something on the cheapest heap. If you just do a loop that tries to transfer stuff from the cheapest to the other heap until it transfers something that isn't rented, then now the cheapest heap has actually 0 copies of things that are available, and other heap has 1 copy of things that are available. So let me go ahead and say that let's say I have a free count for each movie, so it's going to be default dictionary of integers. So for every movie. So movie is the key to cheapest. So for every movie, well, maybe this would be keys. So that returns an object displays a list of all the keys in the default dictionary. Directory iteration, you can directly iterate over the default dictionary access to its keys using key in default dictionary. Okay, never mind. So for every movie in self.cheapest, self.freeCount for that movie is equal to length of self.cheapest of that movie. So in theory it would be 5. At most it could be lower. Can't be bigger than 5. Yeah. Movie and self.cheapest. Okay. Cheapest 5 shops for the movie. This thing needs to be updated still. Rent. So okay. Here, this is one where if it's in the cheapest, then self dot free count for this movie should decrement. So there's one less if it's in there. And then once I transfer stuff from the other heap, if I transfer something that's actually available, then now the free count for that movie is here. I guess free count is only measuring the stuff that is in the cheapest heap. Number of free available cheapest copies. Okay, so the issue with dropping it off is if the drop off is of something that is within the cheapest. If it's within the cheapest and the cheapest is already at the and the cheapest is already above 5, then I need a transfer from the cheapest to the other, the first thing that's not cheap. If this is something that is if this is something that is in the okay, so the price is equal to self.prices for this shop movie. If price, and let's say PS is equal to self.cheapest for this movie, the most expensive of the cheapest. So if this price shop is less than negative PS, self.free count for this movie should be incremented by 1. And I need to transfer movies from cheapest to other until down to max. So while self.free count of this movie is greater than 5, greater than or equal to 5, greater than 5, then heap PS equals heap pop self.cheapest for this movie. Heap push self.other for this movie. Negative PS if self.rented shop movie. So shop is S, movie is M. If this is not rented, that means it's free. So that means self.free count is decremented by 1, and that should stop it. We could technically go down to whatever was just dropped off here, and whatever was dropped off here gets moved to the other one. So that does mean that it's possible that the top of the cheapest heap is not actually available, because this moves something that was available and stops directly after that, so that the next top could be unavailable. So when you rent, determine if it's for the part of 5 cheapest. So for the 5 cheapest, because that's probably still fine, need to pull 100. Price, shop, transfer movies from cheapest to other until down to max. Shop. Movie should be actually misspelled. and then I need a break here. Actually, it doesn't need a break because then it just, the while loop stops it. So, is it possible that this thing never stops? I don't think so, because it shouldn't be doing the loop at all if it's not part of the cheapest. So what's the other possibility for it to not work? So it increments 5 cheapest to have one more free. So some point it needs to reach some movie that's free in the cheapest heap and transfer it. A pop, a push. Yeah, at some point it needs to transfer it. Oof. Okay. And then if I need to rent this here, determine so for the search here, it needs to do something like actually create a list of shops that are actually available. So for every K in self.cheapest of the movie, if you're it's gonna have a shop price in a shop. If self dot free or self dot rented for negative price shop, no, rented takes in a key that is rented takes in a key that is shop movie. If it's not rented, then shops.append do search returns list of the 5 shops. Appends the shop. And then at that point, ooh, but it needs to be sorted by price. So. Price. No, I guess that should work because it's in order. If it's not rented, then append the shop to the list and then just return the shops. I guess I don't need to sort the shops, right? Yeah. So we're kind of in correct sorting order. We'll have the smallest shops first. Okay. If it's not rented, this shop, this movie, would also make maybe a set of stuff that's rented, a set of shops that are rented for this movie, rather than a tuple like this. I guess it's probably the same space-wise. Okay, report. Return the the cheapest 5 rented movies. The cheapest 5 rented movies? Oh. Huh. Earns the 5 cheapest rented movies. Cheapest 5 rented movies. Oh boy. Every time I rent a movie or a movie gets rented, I need to add that to a heap. Every time there's a rented movie, I add that to a heap. I guess. And then every time turns the 5 cheapest rented movies. Retain a heap of the top 5 rented movies, a heap of the other movies, the other rented movies, and then do the same sort of back and forth with them. I think that would probably work. Okay. I mean, in theory, this should be as simple as the other stuff. In theory. Okay, so self dot cheap rentals. Cheap rented is a heap. Cheap rented. And this heap has information about. You should have a heap that is tuples of price. I guess it'd be negative price, shop, movie. Oh, shucks. This is going by negative price, isn't it? So the price is decreasing. So the order's off. I'm pretty sure the order's off here. Because I need to search price in ascending order. And then shop is ascending order. So the first fuck. So I think it should be I'll pen a tuple that is negative price, comma shop, and then shops.sort. So now it should be in correct order and return a list of k of 1, which is the shop for every k in shops. Okay. Cheap rented tuples of negative price shop and movie. Cheap rented. So the stuff that is rented, cheapest stuff that's been rented, should be empty at the start because nothing's rented. I'll need to modify this to only return shop movie, ignoring price. That's the point. And I guess I'll have a self.other rented. Is also tuples of the negative price, or actually this should be positive price, since I want this to be, since I want to know like the 5th or 6th price. Alright, report here. So when something is rented, I guess I need to know also the count of the stuff that is valid in the cheap rented, just like I need a free count. So valid count is going to be 0 here. So when I rent something here, this is determine if if this is 1 of 5 cheapest for movie, and determine if this is 1 of 5 cheapest rentals. So first off, if this price shop is less than or equal to, actually, if the size of my valid stuff in my cheap rented is less than 5, then I automatically include it. Then self.cheapest rental or cheap rented is going to push onto this the tuple that is negative price movie and shop. Is it shop movie or shop movie? So if this is 1 of 5 cheapest, then I automatically push it on there. And self.valid count should be incremented. Else it's already valid, if there's already 5 valid cheap rentals, then only push it onto there if, and then I think I do this transfer thing here, like push onto the others, pop, and then push again. So push pop onto theirs, PS, PSM is heap push pop self dot other rented negative price shop movie, and then take that boundary value and push onto self rent or cheap rented negative PSM. So take whatever's at the top there, oh, this is not going to quite work because it could also be old information at that point. It could be stuff that has previously been returned that hasn't been cleared from this heap. So determine this is one of the 5 cheapest rentals. Valid count is greater than 5. Valid count is less than 5. Heap push self dot cheap rented. Else. Okay, so I think it's right here. I pushed onto this thing. I think I automatically have to push. This new rental, and then I only transfer if it's something that is not outdated. So let's say while true, PSM is equal to heap pop self dot other rented. So whatever's at the top there, and then if this thing is an old returned rental, so if it's rented, self.rented, which takes in shop movie. If this thing is rented, then that's good, but if not rented, then skip it. Okay, so if it's rented, then that means I transfer it onto the cheapest rental and break. No, transfer onto the cheapest rental. Determine if this is one of the 5 cheapest rentals. Okay, so this is rented. We push onto self dot cheap rented negative PSM that would make the self.valid count increment. Are you sure? God. Transfer onto the other heap. Let's run to the cheapest heap, the cheap rented heap. This valid rental. Yeah. Push onto the other heap. Clear off the top. That is outdated information. Once I get something that is not outdated, I take it. I don't think this needs to be while true here. Okay, so this thing should be while. So push onto the other rented this information. Pop from the other rented. If it is not rented, continue. So eventually it should pop something that is a valid rental. Push that valid rental onto the cheap rented heap. And then increment the number of things that are valid in that heap. And then while self.valid count is greater than 5, then again try to clear off the top and try to transfer something from the self.cheapRented back to the self.otherRented. Self.odd count greater than 5. It's less than 5 than whatever. Or it's equal to 5 than whatever. But if it's bigger than 5, then that's not good. Yeah, PSM need pop if this is not rented. Then continue. Go to the next pop. But if it's not, then self.valid count decrements. And at that point, I should transfer back automatically, or what if it's empty? do I automatically transfer the last thing? So if there was too many, there were 6 valids. I think I need to transfer it right here. I don't think I can transfer outside of the loop. A push onto self dot other rented negative b s m. Okay. Okay, so when something's getting rented, if it's if there's less than 5 in the cheapest rentals, 5 cheapest rentals, then automatically push the information for this rental onto that heap. Otherwise, you need to do a bit of dancing here. Push the rental information onto the heap of stuff that's been rented. The stuff that's been rented actually should have increasing prices, positive prices, so that you can get the lowest price of those. And then once you push it on there, then that means that the valid count, so if it's in this else, that means there are 5 valid things in the rental heap, and there's 1 guaranteed correct thing in the other heap. So now you want to transfer at least 1 correct thing from the other heap to the cheapest heap. So while true, take the top off of the other rented. If it's already been rented or it's no longer rented, then ignore it. So it's just outdated information. Otherwise, okay, so it's outdated information. Eventually you'll come up to something that is not that. If I can somehow combine this more precisely. I guess, well, this thing actually doesn't stop, right? If not, a pop pops until something that is actually currently rented is true. If it's rented true, this thing's rented. Yeah, this thing doesn't make sense. If not continue, it's continuing a true loop. If this is rented, then break. So take the top off the other rented until you see something that's actually rented. And now push that onto the cheap rented. Increment the valid count. And then while the valid count is 305, move the top of the cheapest rented And then if that's old information, so that means it's not actually rented, then skip it. Otherwise, it is rented. So now remove that rental and then push that into the other heap. Oh man, that's just one part of it. And then the drop off. Alright, so the drop off. If price shop shucks. So I need to see if this was part of the cheapest rentals. Let's say PSM is self dot cheapest rented. The top of that heap, and if this price shop movie less than or equal to negative PSM, which means it should be part of the self.cheapest rentals, cheapest rented. Then what does that mean? Then that means that the self.free count or the valid count should be decremented, because there's one less valid in that heap. And then I guess I could first just do if the valid count is, if you drop off a movie, would it ever transfer stuff from the, should never transfer stuff from the other rented to this stack, I don't think. Yeah, so it doesn't matter if it's in the other stack. So the other heap, so if it's part of the cheapest rented heap, then decrement the number of valids in that heap, and then while self.valid count is less than 5, let's say PSM is equal to heap pop self.cheap rented, and then check to see if it is actually this is not right. I need to take something from the other heap, from the other rented heap, and try to push it onto the cheap rented heap. So while this is true, heap pop from the other rented. And check to see if this is in fact, if this is not rented. shop movie, then skip it because that cannot be transferred. That's just outdated information. Otherwise, at this point, it is valid information. So now I think I can do self.valid count increment. And transfer this to the other to the self rented or the cheap rented. Push self.cheap rented negative PSN. Okay, so I think this is right. So when I do the search, so get all the price. Get the price, the shop. I think when I do the sort, yeah, I guess it's fine. Price, shop information, it's valid, push, cheap rented. Alright, man, this is just gonna be so hard to debug. Oh my god. Report. Guess it's just going through all the stuff in the self.cheap rented. So let's say results is an array, and for every price shop, say self.cheapest is price shop movie, and self. How do I do the other report? Search price shop in self.cheapest of movies. And self.cheap rented. Then I'm going to do results.append the tuple that is negative price shop movie if it is valid. If self.rented for this shop movie, append this to the results. Result.sort. So now the price should be in increasing order. Okay, and then return I actually need to make this into, actually that's probably fine. Return k of so it just returns 5 as shop in the movie. Shop in the movie doesn't return the price information. So the shop is 1 and the movie is 2 for every k in the results. Okay, let's see where the errors. Yes, I did forget the brackets. Indeed. First argument must be callable or non-default dictionary of lists. C. The heaps should be lists. Index at a range 187. Epoch. So there's less than 5, but there might not be any in the other rented. Guess maybe if there's less than 5 and there's something in other rented. Okay, let's see if they good old wrong answer. Well, somehow it passed 19 test cases before that. That being the case, though, this seems to be kind of hard for me to detect what's going on. Oh boy, oh boy. Those are some mighty obtuse numbers. Movie renting system. I didn't even expect so many numbers. What's going on here? So 69. So 3 is the number of entries, 69 is the number of entries. And then these are a bunch of entries, 69 of them. 3, 1, 2, 3, 4, 5, 6. There's 69 entries here, really? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I must be confusing what n is. There are n shops. Okay. So there's 69 shops, but there's only so many entries, probably like 20. 1, 2, 3, 4, 5, 6, 7. Yeah, 20 or so. So the first thing was renting shop 32 movie 6506. Rent. Let's see where the rent is. Rent is shop movie. Okay, so it's renting from shop 32 6506. It's dropping. No, it's searching for 8501. Okay. Oh boy. Oh my god. So it went through a whole bunch of queries before it got to something where it had screwed up. Question is whether I can try to determine when this occurred or how this occurred. Do 39,165. Oh my god. Input. This is just not really parsable. 39. So this looks to be interesting. 39,165. So this one is the correct, and then these ones are not correct. 39,165. So it should be 39,165, and then I think 546691. But it looks to be in the same. No, yeah. 39,165. And then this is wrong, and then this is wrong, and 39,165. 39,165. 39,165. Oh, 1625. 165. 1625. So like a bunch of nulls before the 39,165. So like probably this one right here. But it should have been 39,165, 39,165. So this was extra. It's like a duplicate. 39,165. Yeah, yeah, it's like a duplicate. I see. I wish I knew which query this is that caused this. 39,165. So somehow there's some duplication in what I'm pushing onto stacks. $39,165. I wish I knew which thing this was. Fact 391625 appears twice. Whereas it should only appear once. So when could I possibly have duplicated some information? I don't think I could have duplicated it at the very start. I think that's possible. Is it? So initialize for every movie, shop price movie, store the price for that shop movie. If there's less than 5 on the cheapest heap, store on the cheapest heap. Otherwise push it on the other's heap. Then transfer the tops. So push onto the other's heap. Push onto the other's heap that price and movie. Take off the top of that heap. Push onto the cheapest heap, whatever was the top. Take the top off and push it back onto the movie's heap, the other's heap. Okay, I think that's all fine. Self.rented is going to be false for every shop movie. Free count for particular movies is going to be 0. And then count the number of cheapest available copies for each movie. The valid count of things that have been rented is 0. And the heap of things that have been rented and the things that have been other things that are not cheap have been rented is 0. It's empty. Search. I wonder. Could do something right here and just to check to see if this is going to do a fix without knowing what the issue is. I can do like a shop set is an empty set, and I can do something like shop set dot append dot add negative price shop, where I then create a shop list, a list from the shop set, shop list sort, return k of 1 for every k in the shop list. Okay, let's see if this would fix this issue. So I don't think this is something that relates to the search. Okay. The results are answer. Is k1 for every k in shops. Search result, and then return the search result. This is probably a more direct way of checking that this was due to that. Okay. I think this is probably a report result. Yeah. Yep. Okay, so this has to do with the how I'm handling the cheapest rentals, cheapest rented. Somehow it's duplicating stuff. Okay, so starting here, when there is a rented item, if the rented item I wonder, the rented item is, what if I rent an item, return that same item, rent it again? I wonder. So if you rent a cheap item, like if it's already appearing in the rented stuff, the item already exists within that, then you could come up with a duplicate. Determine if this is one of the 5 cheapest for the movie. Price is shop movie, so self.free count movie minus equals 1. Need to pull an unrented copy from the other heap. Yeah, okay. I think I just need to make a set here, or I think the easiest thing is just make a set here. Result set. So there could be duplicates because just the way things update itself. Result set dot add negative price shop movie, and then result list is going to be the list based on that result set. And then sort the list. And then return anything from the result list. Result set is not reset. Okay. Alright, do I need to have fixed it in a different way? $85, $35.8241. Alright, I think yeah, this is end of the road for me. It's been, what, close to 2 hours. My brain is absolutely fried. Well, hopefully I can get